Hello, everyone. Good evening and good morning. So I'm Ariel from Portshift. I'm VP Product Management and Business Development in Portshift. I have a long background in security and security of microservices from different roles, and I'm happy to meet you today. Mark.
Yeah, I'm Mark Galpin. I am a product manager at JFrog for the ecosystem, and very happy to be here today talking about this great story we have together between JFrog and Portshift.
Perfect. So let's start. So, before we start, a quick background about Portshift, who we are and what do we do. So Portshift, we were founded in 2018, a group of people. A lot of us have some long background in Checkpoint. Our lead investor is Team 8, which is known for its investments in the cyberspace with many cyber companies. They're trying to shape the industry in new segments. So Portshift is their cloud arm. Our technological partnership covers all the different cloud vendors, the Kubernetes distributions, whether it's CI/CD pipelines, and of course partnership with JFrog on the registries and Artifactory and the Xray, or many companies in the space. So this is Portshift in a nutshell. What do? We provide a cloud-native workload protection. We're securing workloads when they are created, deployed, and of course when they are running. So we don't just stop at any phase. We're continuing protecting all the environment. We are a cloud-native approach, so there's no agent. It's only Portshift. There is using the cloud architecture, using admission controllers as our security tools. We identify and prevent risks in development. So we are integrated with CI and CD pipelines to detect and block potential risks there, and also to collect metadata, which will help us to make the deployment secure. Deployment is also something that we look after. We're checking security misconfiguration, detection, and also remediation options. And seamless segmentation, micro-segmentation, encryption, ingress and egress governance, and in general network policies. So just as one photo instead of all these words, so you can see that Portshift collect and make the first introduction in the CI and the CD phase, and then using Portshift in clusters, in Kubernetes clusters, can protect both the pods, can protect the communication in the cluster, between clusters, and even outside the clusters. So this is Portshift in a nutshell. Mark?
So yeah, what is, who are we at JFrog? We're about, really about managing software, right? And bringing in the vast universe of technologies you're using, whether that be, the different languages you're using from, Java or .NET or Python or Ruby, to deployment packages like RPM or Debian or Docker containers, whether it be your CI platforms, whether it be your deployment platforms, right? We sit basically at the heart of all of it, and we help you bring in all of these technologies. We help you standardize on policies and processes and methods. They say DevOps is people, process, and tools. And we help you standardize those processes. We help you standardize those tools so that the people have the best time of it. And we unify all of this in one platform where we bring you artifact management, security, the ability to store your binaries in a variety of different ways very easily, and automating things and distributing them out to your final end destinations. And this will allow you to provide releases to anyone you need to, whether that be devices, whether that be software that's running on your servers, whether it be other developers, or whether it be your end customers. We're there to help you get your release out fast. So what does that look like? So we have kind of a number of pieces of our platform. First of all, we have Artifactory, which we're probably best known for, which is kind of the core of it all as the artifact management system. We have Xray, which takes all of the artifacts that you are storing in Artifactory and does component analysis on them and security scanning and license compliance checks so that you can be confident that your software is safe to release to production. We have what we call distribution, which introduces a workflow for taking released software and distributing it not just to one site, but to thousands of sites potentially around the globe. And underneath it all, we have JFrog Pipelines, which is a new, fairly sophisticated orchestration and automation tool that allows you to build out very complex pipelines of builds, deployments, and everything you need to automate the lifecycle of your software. So what does this actually look like? So I'm going to, sort of talk through this with Docker, but it doesn't have to be just about Docker. So all software starts with an awesome developer writing awesome code. And in our case today, that developer is creating a Docker container. But it's important to note that a Docker container by itself is nothing, right? If you don't put software inside it, then the Docker container doesn't do anything. Maybe that's something as simple as a bash script and you're using Docker run, or maybe it's something as complex as a full-up Java application with multiple services. Whatever you're building and placing in the Docker container, you can do that with Artifactory, including retrieving your base layer. And as you're building out your system, the developer at their desk, as they're coding, they're going to be resolving their dependencies from Artifactory. And this is great because the Artifactory is local, so they don't have to worry about network issues. They don't have to worry about corporate policy on retrieving artifacts. The Artifactory server takes care of all of that for them. Now, of course, if they request something that the Artifactory server doesn't have, the Artifactory server can go out to the web based on the authorized sources that you configure for it and retrieve that artifact, maybe from someplace like Docker Hub. And it only retrieves it once. So you're not constantly going out to these sources and retrieving them many, many times. You retrieve it once, you store it locally, and then it's available faster and uses less external bandwidth. And eventually the developer is going to commit their code, and it will go into a version control system. And of course, that triggers CI. And you can do this straight up in JFrog Pipelines. You can do this in any number of other tools that develop CI, something like a Jenkins or a Bamboo or whatever you want to use. And this is going to build the container. And while it builds the container, it will be retrieving the dependencies from Artifactory, just like the developer did at their desk. But what's new now is that now it's building the container for record, and it's going to deploy that container out to Artifactory so that it can now start to mature as a piece of software as opposed to as a piece of code. And at the same time that we provide the container, we're also going to provide for it a bill of materials, because there's a lot of information about an object that you can really only know when you created it. You don't really know exactly what dependencies you pulled, in great depth, or the git commit. Like, all of that information is the sort of thing you can only get it while you build it. And so we want to capture that information so you have it for the future. And with that, it goes through and starts the software maturation process. And this may involve maturing via testing as you're going through integration tests and staging tests and performance testing. Or it may be security scanning. And one of the great things about the JFrog platform is that right built in as soon as you upload the artifacts, JFrog Xray starts scanning it. And JFrog Xray pulls in security vulnerabilities from a variety of sources, whether that be official vendor sources from Debian, Red Hat, or Ubuntu, whether that be the National Vulnerability Database, or whether that be one of the finest security databases out there, the VulnDB. We're going to pull all of that data in and associate it with artifacts and tell you if there's any components of your container that are causing a problem. And this is a deep recursive scan of your Docker container to let you know. And we're not just looking for security vulnerabilities, we're also going to tell you about open source licenses that are found in that Docker container for you to deal with as you need to. And then as the software matures, we're going to roll it out for distribution. And there's a number of options. I mentioned earlier that we have JFrog distribution, which would allow you to send it out to devices. Today, we're talking primarily about the use case where you're deploying out to Kubernetes. And so you call maybe a Helm repository from Artifactory, to run a Helm chart that's going to pull a whole bunch of Docker containers and deploy them out to Kubernetes. And with that, Ariel, hopefully you can talk a little bit about, the task of security and governance in Kubernetes once they're deployed out there.
Yes, of course. Thank you, Mark. And indeed, we want to talk about bringing security, governance, but we need to start from the beginning. Now, when you start looking at Kubernetes threats, I think the most dominant one is still vulnerable apps and infrastructure. Now, this is nice infographics. It's not mine. I took it as a courtesy from another vendor, Sysdig in this example. But the interesting thing that you can see in this infographics is that there is a lot of critical vulnerabilities, that in the past, let's say, a year and a half or 2 years, they didn't just come from the code, the artifacts that your developers, the great developers created. Some of it also relates to the Kubernetes infrastructure itself. And when you need to talk about scanning for vulnerable packages, dependencies, and code is still the number one risk. And they're not only critical to the application code that developers do, but also related to the infrastructure itself. Now, detecting it's a continuous process. It's not something, that we can just do it once and it can be safe. It's something we need to constantly monitor because things change. Vulnerabilities are discovered. We can see not everything is under our control, and those, of course, get immediately fixed. But it's really important to make it as a continuous process and not just one time. Now, when we look about vulnerability detection, I call it the anatomy, is that it is something that builds up, right? We need to detect vulnerabilities, detect vulnerable containers code as soon as we start the development. And Mark touched it, usually in CI. In CI pipelines, we want to make this detection, want to verify that, as soon as our developers want to commit the code, they want to build the image, if there are things that violate the policies or violate the permissible level of vulnerabilities that we want to allow because the risk is too big, we can stop it at this time, and the fix is much quicker. It's easier to fix when developers are still in this process. Then, Mark covered it, to continue to the registry. When images are stored in the registries, sometimes they are there for quite some time, or it takes some time. We want to make sure that they are always kept up to speed, or up to date with their security level. And again, things may change since the time it was pushed from the CI. It's not necessarily immediately being deployed. And during this process, sometimes newly discovered vulnerabilities can happen. Sometimes we have developers who make the fixes on the images themselves. They don't go through the CI. They just build a new image and upload it. So you always want to make sure that you know what's the status of the images, if they are trusted or not. But again, it doesn't stop there. It doesn't stop, all the time in the registry. And even when the container is deployed, we want to make sure that there is it doesn't have these zero-day vulnerabilities. It doesn't have anything that is or now known as a vulnerability, even when it's running, because we want to make sure that if there is, we know how to protect it, or we apply the appropriate policies. So I think the concept that vulnerability detection, it's a process. It's not like one check that you do it in once in a lifetime. It's something that you need to continue, you need to keep working on it. It's something that is progressing. Now, when you detect vulnerabilities and you want to remediate them, of course, there are different options to do it, based on the stage that you are. So when we detect vulnerable code in build, we can fail the build. We can create a policy that what are the level of vulnerabilities that we want to allow. If something doesn't meet it, we can fail the build. It can be automated as part of our pipeline process. It could be just like one of this step, and it could be a result in the code that we return. So there's plugins for all those phases. We can also detect vulnerable images in the registries, and as Mark touched it. And those can be mitigated by preventing the image deployment. So we can validate any request that come to deploy an image in the cluster, making sure that this request doesn't bring in a vulnerable pod or a vulnerable image above the level that we allow in our clusters. And of course, we can create a more flexible approach for development clusters, staging clusters versus production clusters. And then the more trickier thing is detecting vulnerable containers while they're running. This is a more complex case because here, if we want to make the vulnerabilities replacement, it takes some time. It takes some time until we identify the owner. We'll let him know that there is a vulnerability. He needs to find a fixed version. Hopefully there is a fixed version. It's not always necessarily that you're going to find a fixed version, but if there is, you need to replace the package, build a new image, test it, and then, of course, deploy it. If there's no fixed version, you need to work on a different package or a different library that you need to adopt. So this is something that takes a little bit more time. And in this time, or during this time until the fix there, the container is exposed. And when it's exposed, we need to provide the adequate security. We need to make sure that no one leverage and exploit this risk. And having this in mind, we'll be happy to present the JFrog and Portshift collaboration in how do we make continuous vulnerability detection and mitigation even when the pods are deployed into the clusters. Mark?
Yeah, so this is a really exciting collaboration. Because when you combine JFrog and Portshift, you have really an end-to-end solution for detecting vulnerabilities, remediating them as need be, creating policies to manage situations in production. And if you use JFrog Xray and Portshift together, you can catch vulnerabilities while you're writing them. You can catch them in the CI/CD pipelines. You can prevent vulnerable images from being deployed or alerted, and you can, detect all the vulnerabilities that are happening in running containers and mitigate their risk right away with workload isolation. And this is really this becomes a really powerful story of using all of the capabilities of Kubernetes and software component analysis and the abilities of the developer and the abilities of, something like Portshift. It really becomes and takes your security to a next level in DevSecOps. And so we're going to show you kind of how this works. I'll be showing you a pipeline where we're going to do some building and upload it. We're going to skip kind of the actual build process, but I'll show you in JFrog pipelines how a build would look and what the end result of that build is in Artifactory. And then I'm going to hand it over to Ariel, and Ariel will be showing you, how when you pull an artifact from Artifactory, what the capabilities Portshift brings to take the data that Portshift has and Xray has, and really, let you feel confident in the security of your runtime environment. So with that,
It's time for a live demo.
yes, the fun part of the evening where you get to see things happen. So, so here's the JFrog platform. And one thing I didn't mention before is that, Docker containers being what they are, localization of that data can matter. And, a lot of people, they have platforms potentially around the globe to address their scaling needs so that no developer has to, suffer by trying to pull a container, across the Atlantic or across the Pacific. But instead, you can have, major artifact registries near every major hub of development. And, you can imagine quite a few different ways that you might go around building. But I will just show you a fairly simple pipeline. And so in this pipeline, we're building an NPM object at the front end. We're building a Maven backend, and we're taking the front end and the back end, and we're combining them together into one Docker container. And then we'll be publishing that container out, running a quick test, and promoting it to production. So some cool things I want to just kind of point out about pipelines orchestration. One of the things that's really awesome about pipelines is the ability to have multiple entry points, right? So each of these little Git symbols, they may be a little bit hard to see on the screen, but each of these are entry points. So if you change this Git repository in the front end, it starts a build with the front end, and then we'll build a new Docker container with it. You could start it from this Maven build on the back end, or maybe you're changing the Docker file itself, which is in yet a third Git repo. Any of those Git repos can trigger the build from the right step in the build, so it doesn't re-trigger things that are already complete, and push it out to wherever it needs to go. And as you run these builds, we collect the build information, bill of materials. And so along the way here, we're collecting, here is the actual container and all of the layers that were pushed. Here's a bunch of layers that were pulled from a base image in order to build this Docker container. We collect environment variables of the build system. We collect security information. So here now we can see all of the security vulnerabilities in this Docker container. And I picked a Docker container with lots and lots of security vulnerabilities. You can see that many of them are fixable. And, wrong page. Sorry. Not all of them, but many of them have fixes, and we can figure out how to fix them. And we also see the license information here. And one of the cool things about Xray is it shows you the entire architecture of the build. So here we have information about the front end, and here we have our actual container. And we can look inside each individual layer and see what's going on inside each layer. So here is a layer with a bunch of NPM packages. Here is a layer with more NPM packages. Let's grab the right layer here. Most of these are NPM packages, but there should be. Yes, here's the Debian packages from starting to get into the underlying OS. And one of the cool things about this is, let's take an individual package that maybe has a problem. So this is the NPM proxy agent. And I can actually rebase the tree from this object, and I can see information about this object itself, see its README, and I can look at its Xray data. And by the ancestors here, I can now see every artifact that I've created that uses this object. And as you can see, there's quite a few builds that are using this particular object and therefore have a problem. And if we go back to our demo application, The cool thing here is that all of this data is available via the API. So here's, for example, the API with the full manifest of the build, all the environment variables, all of the Docker layers, everything that went on during the build. There's other APIs to retrieve the Xray data. And in fact, a lot of this vulnerability information, if you were in your IDE writing JavaScript as you declared a package, we would be able to notify you inside your IDE, hey, this package has security vulnerabilities. Maybe you want to try this newer version as it goes along. So now that we have containers, I will pass it back off to Ariel to discuss how things move forward with Portshift. Did my screen not properly?
Thank you, Mark. Okay,
Yeah,
perfect.
sure.
So let me just share my screen. So maybe, perfect. Can you see my screen now?
Yes, we can see that.
Perfect, thank you. So when you open Portshift and Portshift with the integration with JFrog, so we created this demo. In Portshift, you'll be able to see the workloads themselves. Okay, the workloads which were deployed, you can see who they are communicating with. So that's going to be like, if it's going to be a cluster, you're going to see all of the internal communication in the cluster, but you can also see the communication outside the cluster. Okay, I'm just going to aggregate it for a minute. It's going to be more easier to manage. So we can see the different pods from that we retrieve from our artifact. So we can get the information on the pod themselves. So you can see that they are vulnerable. That's why they are in orange. Okay, and you can also, if you look at them more carefully, you're going to see the information that we can retrieve about the workload itself, where it's the image, the full name of the image, who's the owner, and the version, which will be then again easier for the security team or for the DevOps team or the DevSecOps team to reach the guy and tell the developer he needs to fix the information as well. So this is just give us the connection visibility to see. It can also help us to see if we want to perhaps block or stop this communication. When you walk into Portshift runtime, we'll be able to, based on this information, show you the overall risk of this workload. So for example, in Portshift runtime, we tell you if some workloads are public-facing or not. We can tell you also the information, if there is information about the workload. We can see that there are more risk in this workload than other than just the communication. We can see that this workload, for example, has the high severity, but that's already we know based on the information we extracted from JFrog. But we see that it also has, it's run as privileged. Okay, it can run as a root and can escalate privileges. So we know that the risks there are important. So now we want to do two things. First, we want to examine the vulnerabilities. Okay, so we can see that here, for example, this work came from, we get the source from our Xray. We want to examine the vulnerabilities because we want to know whether or not these vulnerabilities are important or whether or not we want to fix. So, and if it's want to fix it or not. So all this information is available here. You can get, the package name, the image package version, what's the fixed version, if there is. At the moment, there is no fixed version. So there's much we can do. So either we assign it back for someone to develop it, or we can ignore it. We can see all the other CVEs and get this information, whether the fix is available. So at least we know at the moment, what we want to do. For example, we can decide that those which has no fixed version we want to ignore. But that's, of course, not enough, because even if we identify that there is a fixed version we send for developers to fix, we need to make sure that it's protected while it's being deployed. So if we go to our policies, we want to create a policy. So the first probably will be, let's create a policy that block access to JFrog from vulnerable ports. Or what else? We can also create a policy that, for example, prevent pods, or prevent, let's say, external access. So anyone from external access to communicate our pod. So we'll select pod in this example, okay, and we will select our environment. Okay, we'll select the port, we'll select the JFrog demo. We'll skip the layer 7, and then we'll say we want to block any connection that's trying to access our vulnerable pods. And when we apply that policy from now on, it will be much tougher for people to exploit our vulnerable. So this is something that allows us to mitigate, on the first level, to mitigate a potential risk. If you want to go in a more granular level, then you probably want to protect it from accessing other resources, or accessing sensitive resources, or maybe communicating with others. And again, for that purpose, you'll create a new connection rule and apply this mitigation. We have a policy advisor that can also give these automatic suggestions. Another important thing that we want to do is, of course, prevent, once this image is updated or created, we want to prevent it from, again, being deployed. So we can create a deployment rule that will do two things. We'll take any pod that's running on our, let's take, not by pod, let's give it a name. We'll take our pod, okay? We'll make sure that if it has a vulnerability level high and above, we want to prevent it running. We can also apply to it a pod security profile. Since it has a vulnerability, we can perhaps apply a strict security profile to this pod. And that means that from now on, if we want to deploy this pod, we, of course, Portshift will verify that it doesn't have this level of vulnerability that we don't want to allow. Okay, we can select here, for example, to block it. And we also want to block it if it doesn't have our pod policy, or Portshift will apply this pod policy profile to the pod once it's going to be spun up and run again. So by using pod security profile, at least the Portshift strict profile, we can verify that the permissions will not be escalated. We can verify that it will not run as a root. And this is something that we can add on for the next deployment when the pod will be redeployed. So it can be at least minimized in permission, and all the other risks can be mitigated as well. So if I want to repeat again, we get from JFrog the notification about the vulnerable pods. We can see the image, we can see the vulnerability, so we can see it over here. We can see that, where it came from. And then our next stage will be going into the runtime, and in the runtime itself, I can see all the different risks, and then go to the policies, and in the policies, we can, of course, apply the different policies that mitigate this risk. So this is the quick demo that we wanted to share with you. And ball is yours, Mark, again.
So I think we can turn it over to Nara for questions that we have.
Sure. So I see we have a few questions, and please feel free to add any additional questions now. We'll try to answer some of these. Okay. I see a question for Mark. Is there any way I can try this integration if I don't have JFrog Xray?
So yeah, this is allows us to talk about something else. We've got a free tier now in our cloud service. So if you have a Portshift instance or trial and you want to try this out, maybe you're just an Artifactory customer or you haven't tried out the JFrog platform at all, you can go to the JFrog free tier in our SaaS, and that will allow you to try all of the platform that I showed today, pipelines, Xray, Artifactory, and really get a sense of how the entirety of the platform works, as well as tie it in with something like Portshift and try out that integration for deploying to runtime. And you can pretty much set up the entire demo using the JFrog free tier.
Okay, so one more question for Ariel. How does Portshift identify the newly discovered vulnerabilities on the workloads running on Kubernetes clusters?
Okay, thank you. That's a great question. And the concept here is simple. Portshift approach, or at least retrieve the information from Xray, collect it and correlate it. So we know we keep monitoring the images status. And when there is a new vulnerability which is discovered, so the Xray detects and discovered, Portshift considers a new change, and then it can automatically or at least create an alert about this newly discovered vulnerability that initiate the need to highlight the pod, initiate the need to create the policies, and give the user indication that there is something new which was discovered.
Okay, one more question. So Portshift can get vulnerabilities from JFrog Xray? I think you partially answered this already. Okay.
You also get refresher, but you can also show that the user who's the owner of this image, so you can know who needs to fix it afterwards.
Okay, one more question. The vulnerabilities taken from JFrog are taken into consideration when the policy is enforced.
Right, so we can build vulnerability information in our policy. We can take this both in deployment when you want to deploy, but also in connection when we're trying to make network policies. And then this information help us to calibrate the policies. We can also automate it, and you can let it automatically create a set of policies that will happen when a new vulnerability will be discovered.
Okay. Those are all the questions I see for now. If you have any additional questions, you can add them in the Q&A box, and we will make sure to follow up with you via email. I want to thank Mark and Ariel for this great presentation and for their time today. We hope you enjoyed it. And as I mentioned, you will be receiving the recording of the webinar tomorrow. So if you have any additional questions after that, please feel free to reach out to us at webinars@jfrog.com, or you can also send an email to Mark or Ariel directly. You have their email address noted in the speaker bios. Okay, thank you everyone once again, and we hope to hear from you soon. Goodbye.
Thank you. Goodbye.
Bye.